Going to look at this chapter, simple harmonic motion. But firstly, what I want to talk about is that why is it simple harmonic motion, and how does it get the name? Like, why is it simple? And the other thing is, what's harmonic? So, first of all, harmonic is the it's it's actually when an object uh, goes maybe up and down or back and forth. So that object must have an oscillation. So, for example, tides, pendulum, and whatnot. And if you look at the word simple, for instance, we get a pendulum and it's moving from this side to this side. So what we can do is we can derive a sine graph, or if you draw a graph for its displacement, you will see it will follow a sine graph or a sinusoidal wave like graph. So what we see is that the motion is periodical, meaning that it repeats regularly, and the other thing you will notice is that the equilibrium position, it is a singular equilibrium position. It has a maximum acceleration at the equilibrium. As you see in the curve, there is a middle point. You can actually find a point which is the center. But so we for this, I mean, properties, this makes it simple. So so you might have a question that why it's simple and why can there be like stuff like complex? Of course, there are things. There are complex oscillation. So, but we don't actually call this complex. We usually name. For instance, a complex oscillation could be damped oscillation, where, for instance, if you release a ball, it won't be coming to the same height. So, if you draw a curve, what you get is something like this. So, you see this, it doesn't follow a sine curve, and moreover, it's not periodical, and third, it doesn't have any singular equilibrium position, right? So you get the point, like why it's called a simple harmonic motion and how the name thus is given.